Welcome everyone to this. To grab more audience or more students, I need to change my language to English. I hope Nepali students will understand more better for this as well as other students. Let's see. Today's lecture will be dealing on the topic of detection of detection of foreign element. How can we detect foreign element? The topic is how can we detect foreign element in what? In organic compound. Suppose, let us suppose this X is one organic compound, one is organic compound. And what do we understand by foreign element? Foreign element generally can be understood as nitrogen, sulfur, or halogen. Here, this topic has been came in class 11 in theory as well as class 12 in practical in NEB board. So we will be dealing both theory portion as well as practical portion. Let's see. First of all, we should understand what are foreign elements. Let me make one better example for you. Suppose A is one foreign element. A is one organic compound. A is one organic compound containing sodium. Sodium, not nitrogen. Now our main intention is to find out which foreign element is present in this, and how can we know that nitrogen is present in this element, in this organic compound. Nitrogen is present in this organic compound. For this, simply we can't do any reaction, because let us take one example. Suppose if I am taking NaCl plus AgNO3 can easily react and give NaNO3 plus AgCl, which is white PPT, which can be clear that in the presence, if there is the appearance of white PPT, then there is the presence of halogen Cl. But it is not the same case in organic. Let us suppose one CaCl3 chloroform plus AgNO3. There is no reaction. Why there is no reaction? Because you should know that this chloroform consists of covalent bond and AgNO3 consists of ionic bond. So there is no possible so there is no possible chance of reaction. Hence we should apply another method for the detection of foreign element. Let us see. Foreign elements include an example. Foreign element includes nitrogen, sulfur, sulfur, halogen as well as nitrogen plus sulfur. We will be dealing on this today. Let's see. For this process, we should make sodium extract. Let's see what do you understand by sodium extract. Sodium extract is the solution containing sodium as well as organic compound. Sodium plus organic compound. Sodium plus organic compound. To prepare sodium extract, we should take a fusion tube like this. We should take fusion tube. We should include sodium in it, and we should also put little bit of organic solution or sample. Now this fusion tube, this fusion tube should be, now this fusion tube should be placed in a burner until the reaction proceeds or it begins to boil. Then if this organic compound, this is one organic compound, let's see, this is one organic compound. First we have to know if there is the presence of nitrogen in organic compound, then we can write sodium, we include carbon plus nitrogen gives NaCN, which is also known as sodium cyanide, and it gives as this Na plus Cn minus, Na plus Cn minus. If we have sulfur in place of nitrogen in sodium is organic sample, then sodium plus sulfur reacts to give sodium sulfide. Sodium sulfide is Na plus, Na2 plus S minus minus. Likewise, if there is the presence of halogen, as foreign element, then sodium plus halogen reacts to give sodium halide. In further reaction gives Na plus X minus. This is sodium halide. Likewise, one main reaction we include is, if we shall also consist both in 4 number, if we shall consist nitrogen plus sulfur, then what is the result? Let's see some notes before going to that topic. If there is Cn, we say it is cyanide. If there is CNS, then wait for a minute, CNO, we say it is cyanate. And if S is present, it is known as thio. Sulfur group is also known as thio, and nitrogen groups is also known as nitro. Similarly, we apply this phenomenon here. Let's see, if CN then it is, if CNO then it is known as cyanate, if CN then it is known as thio thiosin sorry thiocyanate. What it is? It is thiocyanate. Let's see here. If we include nitrogen as well as sulfur in that organic compound, then we can write as sodium plus carbon plus nitrogen plus sulfur gives NaCNS, which is also known as sodium thiocyanate, which gives is this Na plus CNS minus, Na plus CNS minus. Now we will go on each step of determining the nitrogen, sulfur, halogen as well as nitrogen and sulfur. Let's see in new page the detection of in new page 1 number, detection of nitrogen. First we have to prepare sodium extract. In sodium extract, if we have nitrogen, then the reaction becomes sodium plus nitrogen plus C carbon gives NaCN, which is also known as sodium cyanide. Sodium cyanide can also be decomposed as Na plus Cn minus. That is not compulsory to write. Now let's see. Let's understand first mechanism. What is the mechanism of this reaction which we are going to do? Mechanism. The mechanism of this reaction is simple. Suppose we have test tube. In test tube we have NaOH. NaOH is mixed with Fe. NaOH is mixed with FeSO4. Then it gives dotty green PPT, which is removed by HCl, so we add few drops of HCl, few drops of HCl to decompose, dotty green PPT. Now further we add FeCl3. Now we get Prussian blue or ferric ferrocyanide, or we get ferric ferrocyanide, Fe4 FeCN6 whole to the power 3, which is known as ferric ferrocyanide or most popularly known as Prussian Prussian blue, most popularly known as Prussian blue, most popularly known as Prussian blue. In various entrance examination, it has been asked with the name of ferric ferrocyanide. Has been asked with the name of ferric. Has been asked with the name of ferric ferrocyanide, and sometimes it has been given the this reaction as well as. Now let's see. You have to understand this all this step. First we take NaOH and FeSO4 in test tube, which gives dirty green PPT on boiling or on heating, and when we add HCl, this dirty green PPT becomes dissolved. Then we add FeCl3 on it. Then after adding FeCl3, we get ferric cyanide. Let's see reactions. What is the reaction involving here? First we add NaOH. In NaOH we add FeSO4, that turns to Na2SO4 plus FeOH को whole 2. This is dirty green PPT is due to iron hydroxide or ferrous hydroxide, or ferrous hydroxide. Then the reaction becomes is. Now we leave this component and we move on with this component FeOH whole 2 plus we have got sodium extract is NaCN. So we add this sodium extract and give FeCN2 plus NaOH. Now this iron cyanide again further reacts with FeCN2 plus NaCN, further reacts with NaCN. Most of them ask, now how you understand that it is going to form complex? Let's see. This Fe reacts with NaCN and Na reacts with Cn. They both have CN component that couldn't be formed. It is impossible to form both components with same components. So there is the formation of complex. Something we have to remember, what is that? Sodium complex is going to form and this Cn is going to mix here. Na4 FeCN whole 6, which is known as sodium ferrocyanide. Let me clear you that there are two cyanide. First is FeCN whole 6 whole to the power 4 and another is FeCN whole to the power 3. We know in general you used to write ferric for higher oxidation state and ferrous for lower oxidation state, but just opposite here you will write ferrocyanide for higher oxidation +4 -4 and ferric cyanide for lower oxidation. That's all. Then let's move. I hope you have noted this. We will not bleach the flow of reaction by adding unnecessary things. Let's see, this is sodium, this is sodium ferrocyanide. Now this sodium ferrocyanide, now this sodium ferrocyanide reacts with FeCl3 to give this plus, this is minus component, this is plus component, this is minus component. This is simple double displacement reaction. NaCl plus Fe, here 3 and here 4, you have to remember this, Fe4 FeCN6 whole to the power 3. So naming is Fe component is if we break down, this is like Fe3 plus FeCN6 whole 4 minus. So the naming is first Fe3 plus. Fe3 plus is known as ferric, and Fe this minus 4 is known as ferrocyanide. Ferric ferrocyanide, which is also known as Porcian's blue. Let me wear my glasses. Which is also known as ferric ferrocyanide, and commonly highlighted point is commonly known as Portions. I hope you will manage. My handwriting is not too good. I do write cursive. I'm trying my best to write in simple. Portions blue, which is simply blue in color. Now in this way we can find that the organic compound contain sodium. Organic compound contains nitrogen. Let's see. I'll revise once again. Let's see. First we have NaOH. In NaOH we added FeSO4. After adding FeSO4, this is simple double displacement reaction. Double displacement reaction. This is double displacement reaction. Simply plus minus. You can write Na2SO4 and FeOH whole 2, which is known as dirty green PPT. For the purpose, you could ask one question: why we add? You could be asked why we add HCl. What could be the question? Why we add HCl? The answer is to remove the dirty green PPT, we add HCl here. This is your boiling. Then again, after adding Fe, after adding iron oxide with sodium cyanide, which is sodium extract, we get iron cyanide plus NaOH. This iron cyanide or ferrous cyanide again reacts with the same sodium extract to give sodium ferrocyanide, which is complex formation. Likewise, another way we have reaction is main step reaction. We do have sodium ferrocyanide reacts with iron chloride to give CnACl plus Fe4 FeCN6 which is also known as ferric ferrocyanide or Porcian's blue, which is also known as Porcian's blue. In this way you can detect nitrogen. Let's deal another one which is detection of sulfur. If you have sulfur in sodium extract, then it be like sodium plus sulfur gives Na2S, and if we decompose it, Na plus 2 plus S minus minus. Let's see. In detection of sulfur, we do have two methods. One is lead acetate method or lead ethanoate method. In this process we use lead ethanoate. Let's see, we do have Na2S plus lead ethanoate CH3COO whole 2 gives. Let me draw a structural formula of this. Lead acetate is simply CH3COO-OPB here, and this is 2. Simply we are writing, okay. Then next we have here, this reaction gives simple displacement reaction, plus minus. Then what will be here? This plus will take this minus 1 to form PBS, plus this plus will take this minus 1 to form CH3COONA. This is known as lead sulfide, which in color? Black in color, but I couldn't write here in black, so I am writing with white. This is black PPT. This is black PPT. Let me make fantastic for you. I couldn't make that, okay. Let's see, this is black PPT. In this way also you can determine by using lead acetate, or if you think you are super genius or intelligent, then you can make another also. Another is 2 number. You have sodium. I don't prefer you to choose this. Many lab don't have this chemical. Sodium nitroprusside test. Let me make you clear what do you mean by sodium nitroprusside. You have been familiar with this formula, Na4 FeCN6, which is sodium ferrocyanide. I will make little changes on this formula. Let's see. First changes I will make is I will remove 2 sodium from outside, and FeCN whole 6 not whole 5 dash NO will be adding. This is known as sodium nitroprusside. This is known as sodium nitroprusside. Let me clear this reaction. We do have Na2S by we do have Na2S in sodium extract plus Na2 FeCN whole 5 dash NO will be giving us let's see, this is also simple displacement reaction, minus. This plus component will take this minus component, and this plus component will take this minus component. Can be said by me, but it's not correct. Here you will form complex formation. How can be formed complex? Because both this Na2S and Na2S are similar, so we cannot do double displacement reaction. So there will be complex formation. It's simply Na4 FeCN whole 5 dash NOES. This is known as sodium thionitroproside, which is violet in color. Let me clear. You shall be clear in this reaction. You shall know how to remember the reaction. First, you do have sodium extract here, Na2S, and this is sodium nitroproside. No changes, only sodium. I wrote sodium thio because we added sulfur inside. Here is no sulfur, but we added here sulfur, and this Na2 is added there, so made 4, and this sulfur is added inside, so we made thionitroproside. Simple reaction. It is not so hard to remember as well. You have to remember this Na2 has gone to Na4, and this S has gone inside to form thio here. Yes, you have to remember. Question could be asked like in MCU, the molecular formula of Prussian blue or ferrocyanide, then what will be the answer? You have to say simply this will be Fe3 FeCN whole 6 whole to the power, here 3, here 4, 3. You have to remember 43 if it is in MCQ. Likewise, this all for the detection of sulfur. How can we detect? Because there is violet color, we can see this color after the reaction has happened. And another upper one, we do have black PPT. This can be easily recognized. Let's see another. We do have one interesting topic, like what will be the result if we have nitrogen as well as sulfur in the reaction. This is most interesting. What will happen if nitrogen is there? If there is in sodium extract, we have sodium plus nitrogen plus carbon plus sulfur. Carbon is the most important element of organic compound. Then it gives NaCN. Yes. Then it is known as NaCNS. Let me see upward wait for you. Okay, it's good. This note will be provided in my Telegram channel. Let's see. Then Na plus N plus C plus S will be given to NaCNS, and it will be given, or you can directly message to me. NaCNS will be given Na plus CNS minus. This is known as sodium thiocyanide. This is sodium thiocyanide. This is sodium thiocyanide. Let's see what will happen. Simple reaction. If sodium thiocyanide reacts with FeCl3 gives simple reaction NaCl plus FeCNS whole to the power 3. FeCNS whole to the power 3. We should understand that if NaCN sodium thiocyanide reacts with FeCl3 iron chloride to give NaCl plus FeCNS whole 3, which is known as iron thiocyanate. I made blondie mistakes here. Let's see. Here you should write not cyanide, cyanate. We say cyanide for Cn, cyanate for CNO, CNS thiocyanate. Sorry for that. Let's see. Let's move on. Now this is iron thiocyanate. You could say, what is the result? How could we recognize this? There is one reaction just like this. Iron thiocyanate has blood red color. Iron thiocyanate has blood red color. I want you to remember, if nitrogen is present, there is. If nitrogen is only present, there is Prussian blue. If sulfur is present, lead acetate and sodium nitroprusside test. Lead acetate gives black 50. Sodium nitroprusside test gives violet, and this nitrogen plus sulfur combination gives blood red color. Now we have last and the final topic of this session, that is detection of halogen. I will be describing this on simple chart. Let's see. If you have simply if you have NaCl, no need to make sodium extract. NaCl, NaBr and NaI reacts with AgNO3 to give different color combinations, like let's see. If first it gives white PPT, then it is known as, if there is the presence of chlorine, if it gives pale yellow, if it gives pale yellow If it gives pale yellow, then this is Br minus. If it gives yellow, then this is iodine. Then this is iodine. What is this? This is iodine. See, simple reaction. If there is NaCl or NeBr or NaI, simply reacts with AgNO3. Simply reacts with AgNO3. If there is white PPT, it is chlorine ion. If there is pale yellow PPT, pale yellow, then it is Br minus. If there is yellow, then it is iodine. If there is yellow, then it is iodine. Let's see. Let's make one simply reactions. Reactions is important if you are writing it in theoretical. No one have time to read your theory. They have time to see your reaction only. So be careful on that topic. You have AgNO3 plus NaCl. First gives AgCl plus NaNO3. AgCl plus NaNO3. Now again this AgCl reacts with NH4OH to gives Ag NH3 whole 2 whole Cl plus H2O, and this is known as diamine silver chloride. Diamine silver chloride. That's all for today, and one last and final question that I need to write here is, last question of this session, why Lacinaise extract or sodium extract, this is the name of the scientist, extract is boiled with conch HNO3 while testing for halogen. What is the reason? In test of halogen, we need to boil the sodium extract. We need to boil the sodium extract in AgHNO3. What is the reason? Let's see. Sometimes halogen compound may have sodium and sulfur. Sodium and sulfur. In case of sodium, not nitrogen. Nitrogen and sulfur. In case of nitrogen and sulfur, reacts with a sodium extract. If there is nitrogen, then gives NaCN, which reacts with AgNO3 to give AgCN plus NaNO3, and if there is sulfur, it gives Na2S plus Na2S plus AgNO3 gives Ag2S plus NaNO3. This AgCN gives white PPT, which can be this gives white PPT which has been came for chlorine but here is presence of nitrogen, so it can mislead. Likewise, if Na2S directly reacts with AgNO3, sometimes in halogen compound we can have nitrogen and sulfur, and it can react with sodium extract to form NaCN and AgNA2S, and NaCN again reacts with silver nitrate to form AgCN, again reacts with silver nitrate to form AgCN, reacts to form AgCN, which gives white PPT. And further we have also read in this test reaction that if this compound reacts with AgNO3 and gives white PPT, this is known as Cl minus ion. Likewise, if sodium sulfide reacts with AgNO3 to give Ag2S, which is black PPT, we have found black PPT in test of sulfur. Like if Na2S reacts with PbCH3COO lead acetate to give PbS plus CH3COO. This is black PPT. This is black PPT or not? This is known as black PPT. Let's check. Let's see here. This is black PPT or not? This is black PPT. Yes. Then let's see downside. We move on downside. This is black PPT. So before carrying out the test for halogen, the sodium extract is boiled before carrying out the test for halogens. The sodium extract is boiled with conc HNO3 to remove what? What is the reason of adding? We have deal about the consequences. Now what is the solution after adding conc HNO3? Let's see. If we have got nitrogen and sulfur in halogen compound and it forms NaCN, then it reacts with conc HNO3 and boil to give H plus minus to give HCN plus NaNO3. This HCN is volatile and it can be taken out. It mixed on surrounding. Likewise, if there is sulfur, then it becomes Na2S plus conc HNO3 plus minus. What it gives? Hydrogen sulfide. Hydrogen sulfide is volatile plus NaNO3. This both compound can be removed, so we should add conc HNO3 and there is no formation of white PPT and as well as black PPT. Hence we can say that we should add conc HNO3. This much for today. Thank you.